stuff I need to know. These are dealing with computer systems. I have knowledge or information that I need to keep and would like to know, where do I put it? What do I call it? And then once I do that, what did I call it? And where did I put it? And finally, how do I access it now and in the future? This is what we want to talk about, is what do we do with our information? Libraries, physical libraries, use library science. Environment that I didn't realize was really location-based. Everything is located physically so that we know where to put things before we even have our first book. We've divided it, built locations for our books, and anyone can come in and find them. And we have our card catalog, which is our index into our used library, which we can use if it's convenient for us, or we can walk around and all the books are physically located in groups of content. So math books and algebra books are organized, and so on. So anyone can use it. So whether you're 2 years old or 90, we have the same access, the same knowledge base that we need to find what we at that particular time need to find, which is why libraries really do work, because they are location based. And anyone can restock, so that we know before we get our first book where it's going to go. And as we lend books out and bring them back, the physical location is already known. And so anyone can restock, can pick up a book and put it in its place. And new books know their place. So as I get new books, new content, new information, and it's been cataloged. I owned a cataloging company at one time. It was a one-man shop, but he did National Library of Medicine cataloging, and so I learned quite a bit about the dealing with cataloging systems and the different styles from Dewey to LC to NLM cataloging. And then we have colon classifications, and then NASA has their thesaurus. So there's a lot of examples of information structures trying to convey what the library did in our computer technology. But unfortunately it hasn't worked. So our computer knowledge is independent. We don't have physical locations for anything. We have kind of a human-based, well, what do I call it? I have no idea. Where do I put it? I have no idea. I just, to us, it's just one big room. We throw everything on the floor. First 10 years of marriage, I had my tool on my hand tool. I did a lot of work around the house, and they were in a closet for 10 years until I finally built a garage where I could actually have my tools out and organized and have physical locations for them all. But everything on the floor is why we build libraries and cataloging systems. But unfortunately, in our computer knowledge, we don't have anything like that. But that's what I'm trying to build, is something where we don't have to throw things on the floor. So our current placement technology does not work. We have parent-child relationships, which are files and folders, and that really doesn't work because, we have multiple copies of things, and, where do we put them, and can we find them again, and what did I call it, and which one is the latest, and so on and so on. And we have nested structures, so this thing contains multiple of those, and this is how HTML is built, through a nested structure. And most of our documents are actually RTF is HTML, just less readable. And we have a hierarchical, which is our business organization, but that doesn't really help us because we're stuck with we have linear lists of, and that, we have tables and things like that, and then we can have sorted and grouped derived information structures that we can derive. So we get to words and terms, which is really, how we name things. We have subject headings and so on in our classification scheme, and that is a whole different world. This is how we access knowledge in our brain or anything. So when we think of something, elephants, we have a word for that. And that word then conveys all the information that I need. And somehow our brain relates all that information without duplication and can be pulled up in any order at any time for any purpose. And then we have groups of terms, which are sentences and paragraphs. And this is how we speak to each other. And library systems used to work. They were related by terms, subjects and authors, related by context, which was their subject headings. I'm talking about when we went digital with our library science, all this kind of got thrown out. And then they're related by location, and location. The libraries really did work because it was location based. And we have to get back to that, so our current database technology, it's a bad technology, impossible to modify. It's based on what you know. So it's your responsibility to name the tables. Naming conventions are not a technology. We try thousands of different schemes. I've worked with hundreds of databases, hundreds of companies, and I've only seen one database that I actually thought was designed appropriately. But it was designed by one person. And when we have multiple people who knows bad technology, and we have too many chefs. So if it's done by one person, that one person gets it so that he or she can remember, what is what and what the purpose of the whole system was. Right now our systems don't tell us this information. And we have third-party organizations, so Oracle and Access and SQL and all these third-party databases they allow us to do resultant tables. But it doesn't tell us anything about the information itself. And we don't have any real external relationships. We don't know the relationships. We hard code those in scripts, but that relationship is not known. And we have parent-child relations, which is we can have schemas. We separate some of the tables by technology. And so on. We know databases, and so knowledge is not my knowledge. My knowledge in our current software technology is maybe documentation. So my knowledge, I have to put in documentation. Okay, I know that these three tables relate to cars or something, and I can document that. But then documentation is an overhead that we shouldn't rely on. But it seems like our whole world is documentation. I was looking at specification for the USB protocols, and that's 300 pages for a simple bit string. The bit string itself should tell us. The hardware should tell us that, not. And we have assumed knowledge. These are expectations. Derived knowledge are AI assumptions. Worked at knowledge, which is our computer software source code. So we work at putting our knowledge in source code, but that is the wrong place to put it. We have assumed learned knowledge, which is, to me, a religion. And we learn by trial and error. This is really what we as software developers really do, trial and error knowledge. We don't know. So we need a place to put knowledge, and it should be location-based. Location means that it's physically located next to where it should be. And it should be more, now have more than one location. So our libraries, we're looking at more and more client-server technologies that we can't really utilize to its fullest extent. But we need to be able to treat all of our computers as if it were one. And when we put something, it should be meaningful, that there's a reason I put it there. I know it. Everybody else would know where to put it. We have to have, just like our libraries, we have to know where we're going to put things before we get it. The whole thing, we need to derive. And when we do put something, it should be fast. So when I think of elephants, I'm not pulling everything I know about elephants immediately. I'm only getting the things that I need. And when we're in our when we were dealing with smaller data sets, less knowledge, we really don't have very large applications. But we want the place that we build to be self-aware of, I have an image, or these, it should know everything that I know, or at least have the ability to know everything I know about that image or file or accounting system. So if I have an accounting system, it's just one system, and everything within it knows everything related to it. So it's a collection of, as knowledge. So it's a collection of dog names. It's a collection of employees. It's a collection of, and then finally it needs to be qualifiable. Right now we have to write programs to qualify that I only want that chapter out of that book, or these records out of that book. But we could put that. We don't need to be writing applications for everything. We have this system needs to be qualifiable for all of our information. What related knowledge? The knowledge itself should be knowledgeable. I hate the term metadata. To me, it's stupid. Basically, we don't have any logic that applies to it. It's just there for our purpose. No, we need knowledge that is actually part of our functionality. So here's some tables. I need to know all the tables we have. I need to know those ones. I need to know all the views that reference the employee table, or these triggers. I need that organization so that I can ask the questions that I need to do my job. And so the knowledge itself is knowledge. And that knowledge we need place. We got to get it out of people's heads and put it into our system. So we have parent and child, siblings, which is our standard kind of knowledge. There's nothing wrong with it, but we can't rely on it for everything. We have ownership and ranking, which is back to our hierarchical structures. And we need to see and see also. So in our thesauruses, we have, and so in see also, so compilers, you may want to reference and say see also computer language. So we need this kinds of knowledge in our structure so that anybody walking in would immediately know what it is they're looking at, even though they have a word that doesn't really relate to what they're looking for. We have no memory, so we have knowledge that isn't remembered, which is vision, our vision. We don't remember what we saw. Our brain doesn't register that image. We can remember the names of the color, location of things, but we see so much that it doesn't even try to store things. And most of our applications run and do calculations, so we have things that we don't really need to remember. And then we have short-term memory, which are things that I'll remember while I'm running this application or something. And then long-term, which is our stored information. And so we need to realize that in our access to knowledge, that some of this is long-term, some of it's short-term, and some of it we don't need to remember. And that needs to be part of the knowledge that the system has. And we have a working knowledge, which is how we perform something. So yes, I have a handsaw and a board. I need to know how to cut that, how to use that particular tool. And so our logic, our source code, if you will, our scripts that we tell it determine the actions that are going to be performed on the knowledge that we do have. And related knowledge. We have related knowledge. I have a dog, Fred, and he is owned by Aunt Martha. Okay, that related knowledge is the owner. When I'm at dog, I can say who's the owner. But I can't, and then when I'm at Aunt Martha, I can say who owns, does she own a dog? So it's this related information that we need to keep together always, so that if I'm at the dog, I can always ask, and it doesn't have to go look up something else. It knows when I'm at dog, I know the information that I do know, which is critical. I do know that I do have ownership information, or I don't have ownership information. Historical knowledge. Yes, okay, when was the dog bought? Who, at what store? What was, did I pay with cash? How did this come about? And that historical knowledge is also related. Let's say we have a list of cars and we want just those that are Chevy cars. And so we have the indexes and things that we use as knowledge to access our information. First things first, where do we put knowledge? This has to be done before we even start. Where do we put it? We need to know that before we even start building our computer systems. Identifiers are not organization. We have to remember that. Look, yes, the words mean something. Identifiers should not be our final say in how we organize things. It should be the knowledge itself. That we know that a shopping cart can hold certain items in a grocery store and it can't hold other things. So if I buy a couch, a shopping cart isn't going to work. We'll need a cart. And so we use the terms to reference real information that we're after, which is can this particular thing perform as I want it to? And that knowledge needs to be in there. Classification schemes are secondary. Yes, we classify things. It helps in our card cataloging system. It helps with figuring out where things are put in reference, but it's actually the physical shelves or the locations that we put them so that people can find it without the classification system. So we go in the library. I don't know anything about the classification system. That's somebody else's job, and that's the way this should be. Jane should do the classification, not humans. I don't go into a library and say, oh, well, you should really put your history books over here. No, it doesn't work that way. It can't be, every individual's you go into somebody's kitchen, they're going to put their silverware wherever they want to put them. And that has no realistic expectations on my part of where they actually put them. I have no idea where you put your silverware. You have 3 drawers. It could be in any of them. Design, organize, and label the boxes first. So if we say we're going to put something in a location, that box, that thing I'm going to put it in, should be organized first, which is, where do we put it? We need to do this first before we even start. We never assume knowledge. It means that we never assume that any piece of knowledge is going to exist, which means we don't know what books we're going to actually get off the truck. They said, here's our library. We built it for 200,000 books, and we get 200,000 books, start putting them on the shelves. And everything, immediately, everybody knows where they all go. There may be some reorganization because we got too many math books or something, but that's, But with computers, we don't have to worry about that. That's instantaneous. But in the library, unfortunately, but that has all been pretty much designed. So someone new someone who just came into your organization should know what is available, what information is available. That's what I need to know. What is it? I need to know what is not available. Look, we don't keep that information. I need to know that. I don't want to I spent 4 days looking for something and it just wasn't available. I was working at Conoco and I'm left-handed, so I hate pens and I'm too heavy-handed for mechanical pencils. So I like pencils. They just, I can write with pencils. I can't do ink. If I'm with left-handed, you're going to smear the ink. Long story short, I couldn't find a pencil sharpener anywhere in that building. Period. So I had to bring my own. But I spent good. And we need to know where to put something new. We have to have that already available to us and have the ability so that it's knowledgeable. It's not just in my mind where I put it. Right now, it's all up to me. Where do I gotta put employees. I'm going to keep a list of employees. Where do I put it? What do I call it? How do I organize it? What separation is there? And redundancy and security and all the other things that I have to do. That should already be known. And I should know where to look for something. So, where did I put it? Where is it? About the current projects, I need to know where to look. All of this is all generally not documented. It's just word of mouth. Oh, well, go look in there. I was working at this other company, and they kept saying, well, you got to do something with invoices. Well, I kept looking at it. They didn't have invoices. They used their particular accounting system did not have an invoice database. They used purchase orders as an invoice because they could get that system. Apparently they had to pay more or something to get that sub. Don't ask me. It was a big company too. And finally they, after a couple of weeks, I finally found out that they did not have invoice. We need to know what we're looking at. We have to have the ability to browse and browse knowledge, not just the things that somebody wants to put out there to browse. We need all knowledge. So every file, every data structure, every substructure, every proprietary structure, everything we should be able to see it. And the whole universe, we're now linked into the whole universe. We have connectivity between machines and that browsable. And we need to get just what they need. Look, I don't need the whole employee data set. I just need those in my department. So I created an actionable cell. Instead of files and folders and objects and classes and subclasses and all this, I said, no. I'm going to build an actionable cell. Just one thing. So it's a physical separation into knowledge units. It's based on size, importance, and or usefulness units. And that can be grouped into bigger physical units. So we may have purchase orders, and that is grouped under accounting system. So purchase orders knows all its siblings. It knows accounts receivable, accounts payable, and all the other siblings in an accounting system. And then that accounting system knows everything that's related to inventory and so on and so on. So the whole structure is physically located, physically on the disk, physically located so that it's accessible, qualifiable, and get just what we need out of that particular system. As direct access. So our naming conventions is we actually know the block number on the disk drive of where that piece of information resides. So we're not having to search through files and folders and so goes on. And indexed when appropriate. So our record index, okay, here's a list of cars that we have. We build indexes so we can get directly to the car. And it's aware of its own context knowledge. So when we put something into the system, it immediately knows all its related information and everything that it's responsible for, and yet it still knows who owns it and what it's responsible for, and so on. And access. So it's addressable. We could have a unique ID, could have a name, category, or some sort of relationship, and that should all be done through our naming system, not a separate software. I mean, we have so many different softwares just to get something. We have databases and file structures, and this application only works on images. This one only works on, on Excel tables we have. And no. Everything is accessible by every application. And it's searchable. I can deal with anything relating to Christmas. And that should be the whole concept here, is to get rid of files, folders, and databases. We don't need them. The cell. We have one cell which contains the universe. So every computer out there, everything. And then that cell contains a cell listing all machines in the world. In the cell, there's a cell for each machine. And in that cell, there's a listing of all hardware on the machine. And then a cell for each hardware device, and so on and so on. And so we get down to every bit and byte is all related to that one cell. And this is a parent-child relationship, yes, but we go a little further. And we bring things together as one or many, which is what we actually need. So I created dynamic link libraries, DLLs, and you may not be aware of it, but basically they are the programs, parts of the program that are called by every application. So when you draw on the screen, there's a DLL out there that has the logic that you say, put this character on the screen. DLL, which is in your system folder. And the reason I use this, I could have used fonts. Fonts, basically things that are divided, have many, many parts to them. It's like a car. If I said car, and then, the cell for a car would contain all the parts on the car. So you could have, and you might want to separate those into body parts. Okay, these are the frame parts, and these are the body parts, and these are the engine parts, and these are the, interior. Anyway, we would break those things up so we could access just what we need. So we have a set of data and logic that makes up an executable. That's what's actually in the. So when you see a deal, it's actually a set of data and logic that is part of an executable, and that's all it has. But what if I could put in an entry for the format declaration statements? So I could describe that format of the DLL, the binary structures. I have a video on that. But that actually describes, so that I don't need source code anymore to read the DLL. The system can dynamically go in and parse the structure of the proprietary format and actually create a view of it. Okay, so we could store that it's in the same file, but separated. So the cell has files and folders inside of it. So I can treat it as a cell. And so I might want to put the declaration statements. I may want to put in an entry for each object, each part of the file, a description and indexes. So if it were a car, I could say, okay, these are body parts, and I could put in that. I could say, okay, the door handle is this part number or whatever. So I could create all of these things, and then I could have an entry for documentation. Okay, these are special notes that I need, or I may have an entry for history of modifications that I've made to the car or something. And so this one cell can contain all of this information as one unit. And yet, we could still access each part of it independently, directly, without looking at the other parts. And we could group them and put in saying, well, when I say X, I meant entries 1, 2, and 3. kind of thing. So software is great. We can do anything we want to with software. What I'm saying here is that the cell is, we get rid of files, folders, and databases, and we build a cell so that things are physically related and we can pick it up and move it as one entry. And then that cell knows all that it contains. It can tell you, oh yes, I have an entry for all the car parts. I have entries for, and I've separated it into these parts of body, frame, engine, Maybe we separate the carburetor. Who knows what we want? It's really now up to the human. Now has a place for everything. So if I have a new car part or a new thing in a library, I immediately know where to put it. And it's all parts of one namespace. So I've created a namespace, which is my intelligent namespace video, which says, look, I can access anything within this thing independently. So I can say dll.section in the library, or I could say, car.body parts, or whatever I wanted to say. So, or I could say bodyparts.car. Anyway, there's a whole slew of just putting things in the namespace. That way we don't have to write programs for this. It's all already available. As the world turns, we're no longer just one machine. We're talking about multiple machines on our machine. We have cores. We organize it. This is not AI or anything. This is physically location of libraries, books in a library. We need this information. We put a new book in our library, a new piece of information in our computer system. It immediately accounts for it, and I can ask it anything that's related. So thank you for your time. Strange, but we have to change our technology because it's not working. Until next time, thank you.